What is light? This is a question that can be answered very simply or be made exceedingly complicated. A simple way to answer is to say that light is a type of wave that causes objects to be visible to human eyes. The sun produces light, and that light bounces off objects and into our eyes. This makes it so that we can see things because the brain can interpret that light and tell us what's out there. Pretty simple. But what is light actually made of? How does it work? That deeper question is answered by physics, and it took centuries to figure out. An important step happened in the early 20th century. We discovered that light was both a particle and a wave. That might seem impossible, it might make you scratch your head, and that's certainly the way physicists felt about the idea at first. But thanks to Albert Einstein and Max Planck, we know that light can act like a particle or like a wave, depending on the circumstances. This is called wave-particle duality. In today's lesson, we're going to talk about light behaving as a wave. The wave theory of light was the way we first understood light. The theory was spread most significantly by Robert Hooke and Christian Huygens in the 17th century. They predicted that if light was a wave, we would see certain things. We would see that light could reflect off shiny surfaces, refract or bend when moving from one material into another, and diffract or spread around objects or when moving through slits. It should also be possible to see interference, where peaks or troughs of waves add up to create brighter light, and peaks and troughs cancel out to create darker areas. All of these things were seen in formal experiments by the 19th century, but some of them are easy to see in your own home. It's obvious that light can reflect. You just have to look in a mirror. Light bounces off the mirror and goes into your eye so you can see yourself. It's also obvious that light can refract. All you have to do is put a spoon in a large glass of water and watch how the spoon appears to bend. That happens because the light is bending as it moves between air and water. Both of these things can be seen even more clearly in a laboratory using beams of light or lasers. Diffraction was harder to recognize and took until the turn of the 19th century. Thomas Young showed that light spreads out when it goes through a gap, and that two light sources can interfere with each other, creating patterns. When the two peaks or two troughs from the two light sources hit a screen at the same place, you get a bright area. Additionally, when a peak and a trough hit the screen at the same place, they cancel out and you get a dark area. This can only be explained if light is a wave. All this evidence convinced people that wave theory of light was completely true, and that it was all there was to light. So when Einstein and Planck used the photoelectric effect experiment to show that light could also act like a particle, it came as quite a shock. Light is a type of wave that causes objects to be visible to the human eye. The sun produces light, which bounces off objects and into our eyes. But explaining what light is made of is much more complex than this. In the early 20th century, we discovered that light is both a particle and a wave. This is called wave-particle duality. But this came as a surprise, because before that, we were sure that light was a wave. This previous theory was called the wave theory of light. We have some pretty solid evidence to support the wave theory of light. We could see that light could reflect, bounce, refract, bend, diffract, spread out, and interfere, producing dark and light patterns. These things could only be explained if light was a wave. The work of Einstein and Planck showed that light was also a particle, which came as a big surprise.